Hello and welcome to helpyourmath.com. In this video, we are going to look at question 6 for the Math 206.5 final exam review. In question 6, we are given a gorgeous sign graph. I know it's a sign graph because it tells me right here that it's a sign graph. And also one more important piece of information is that there are no reflections, but we'll talk about that in a minute. So our parent function sign graph, with any sign graph, a period will start in the middle, go up to the top, go back to the middle, down to the bottom, and back to the middle. So one period of a sign graph will always look like that. But of course, sign graphs have infinitely many periods. That's just one period. What we want to do here is figure out the equation of g of x based on figuring out all the pieces of information we need that go into the transformations that we see here from that parent function sign of x. So our ultimate goal is going to be figure out what the values of a, b, c, and d are, and then writing the equation with those values plugged in. Let's get started. First, what is the period of g of x? So to identify the period of g of x, we need to figure out where is that middle point. So where is the first time in this graph we see a point that's exactly in the middle? And a point that's exactly in the middle means it's exactly halfway from the tallest point of the graph to the lowest point of the graph, which it looks like it's going to be right here. So we're going to really take note of this. And we can verify, so this midline here, which coincidentally answers letter D, this midline is 2 units from the top and 2 units from the bottom, so it is exactly halfway. So that's good. I figured out where the midpoint, the midline is. Now let's use that. So here's going to be the first point of the period, right? We start in the middle, we go up to the top, back to the middle, down to the bottom, back to the middle. That's going to end this one period. We need to figure out the period is going to be the distance in x coordinates. So the horizontal distance from those two. Let's go up to the top for the units. Uh-oh. We don't have units for either of these, so that's it. The question's done, right? No, we're going to figure out what the units are. How can we figure out the units? Well, we're going to use the units that we were given. This was given in units of pi over 4s to figure out what these x coordinates will be. To figure this out, this first x coordinate is exactly halfway between 0 and pi over 4. What value is exactly halfway between 0 and pi over 4? Well, if you're not sure, and that's okay, what we're going to do is we're going to add those two x coordinates up, x values up and divide by 2, right? We're going to take their average to get right smack dab in the middle. So we're going to do 0 plus pi over 4 divided by 2. That's going to be pi over 4 divided by 2, which is pi over 8. So I know this right here is pi over 8. That's exactly halfway between 0 and pi over 4. Looks good. To figure out this x coordinate right here, we're going to do the same thing, but we're going to add up the two values that surround it. So we're going to look at pi over 2, which I'm going to not fully write out just the second, plus pi over 4. And the reason I didn't write pi over 2 is because I know that I'm about to add two fractions. If I'm going to add two fractions, I need a common denominator. 2 I can pretty quickly rewrite as 4 by multiplying by 2 over 2. So I'm going to multiply by 2 in the numerator and 2 by 2 in the denominator. Now I have that common denominator. And then we want the average of those two, so we're going to divide the whole thing by 2. We get 5 pi over 4 divided by 2, which will become 5 pi over 8. Okay, so this x coordinate here is 5 pi over 8. So now I know the starting x coordinate, I know the ending x coordinate. To find the period, I need the difference between those. So the period will be 5 pi over 8 minus 1 pi over 8, which equals 4 pi over 8. And we're going to simplify that down to pi over 2. Hooray, we have the period. Yay! Now, what does the period, which variable does it correspond to in our equation for g of x? It corresponds to, it's not exactly, but it corresponds to the b. We use the period to determine the b value. So this is going to help us determine the b of the equation. We can go ahead and figure out b now since we're going to have to do it eventually. We might as well just, while we're here, do that. The period, where am I going to write this? Up here. The period is equal to 2 pi divided by b. We don't know b, but we do know the period. So we can say, okay, pi over 2 is equal to 2 pi over b. And then we could cross multiply or whatever strategy you have for figuring out b. We get pi times b is equal to 4 times pi To get b by itself, I'll divide both sides by pi, and I figure out that b is equal to 4. All right, yay, our first variable. B equals 4, 3 to go. Let's see what question B asks of us. What is the amplitude of g of x? We actually kind of already answered this question back when we were looking at question A. So we did a lot of work for question A, but it's a big payoff because it's going to help us with part B. The amplitude is the distance between the midline and the tallest point in the graph, or the midline and the lowest point in the graph. Either way, you should end up with that same answer, right? Either way, there is a distance of 2. So the amplitude is 2. The amplitude helps us determine that variable lowercase a in the equation. The amplitude is always the absolute value. It's the positive version of lowercase a. But lowercase a we know is also positive because it says there are no reflections. If there was a reflection, then maybe a would be negative, but no reflections, therefore a is positive. Okay, 2 down, 2 to go. A is 2, B is 4. What is the phase shift? So the phase shift is the distance between the starting x value and where we actually, the starting x value of the parent function and where we actually start our graph. So normally a period on our parent function will start at 0, but we have ours starting at pi over 8. Again, we get to use letter A to help us. Yay! Which means we have a phase shift of pi over 8. Good thing we put in all that work already. So the phase shift, again, it's normally a parent function would start at 0, but we're starting over here at pi over 8, so that would be our phase shift. What does the phase shift help us determine in our equation? It actually would help, it's going to help us determine C. So the phase shift itself, which I'm just going to abbreviate to PS, is equal to C over B. Now, we know the phase shift, and we already know the value of B because we calculated that all the way back in question A. Again, question A is really paying off. So we know the phase shift is pi over 8. We don't know C, that's what we're trying to figure out, but we know that B is equal to 4. Whatever strategy you want to use here to figure out the value of C will be just fine. If I cross multiply, I get 4 pi is equal to 8c. And then if I divide both sides by 8 to get c by itself, I have 4 pi over 8, which is going to simplify to pi over 2 is equal to c. So now we know that c is pi over 2. Okay. Great. So we're going to put that, where are we going to put that? Up here. C is pi over 2. Fabulous. Letter D, what is the equation of the midline of g of x? Guess which question is going to help us with this? That's right, question A. The equation of the midline, so that midline is a line, and it's that line that's exactly halfway between the lowest point of the graph and the highest point of our sine graph. And it's a horizontal line, which means it's of the form y equals. And we're going to get y equals, it's down at -3, right? So that now we're looking at the y values. Those y values, the middle of the y values is at -3. And what is this going to help us with? This is going to help us determine the value of d. So we also know d is equal to -3. And we actually have enough information to write the equation of g of x. However, we have a little bonus question here. It's asking us for the 5 key points for one period of g of x. We already have almost all of this done. We just have to take it and rewrite them as ordered pairs, or I prefer to use a table. It just keeps me a little bit more organized and it's a little less messy. See with your instructor if you can use a table too. 1, 2, 3, 4, 5. Okay, and we have x and g of x. So the first key point, it's going to be that first point of the period. It's going to be x is pi over 8 and y is -3, or g of x is -3. So we have pi over 8, -3. Next, we're going up to that tippy top. So this is going to be the next key point. This is located at pi over 4 is x, and -1 is y. Going back to the middle right here is our next key point. We don't have the x coordinate, so we're going to have to do a little bit of work for this one. Do you remember how we find this particular x coordinate? We need exactly halfway between pi over 4 and pi over 2. So what we can do is we can say, okay, I'm going to take the average of those, pi over 4, and remember we're going to rewrite pi over 2 as 2 pi over 4. Pi and divide it by 2 because we're taking the average. Pi over 4 plus 2 pi over 4 is 3 pi over 4 over 2. And we're going to just squash those. We're going to end up with 3 pi over 8 when it's all said and done. So the next x coordinate will be 3 pi over 8. And the y coordinate, we're back at the midline, -3. Okay, we're going down to the bottom of the graph. The x coordinate is pi over 2. Down at the bottom, that puts us down at -5. And back to the middle, we're going to end this period at 5 pi over 8 and -3. So those are 5 key points for one period. They look gorgeous. Hopefully everything kind of works out. You can always check your work here with all of the different pieces of information from A through D. Lastly, we're just going to write this equation. So I'm just going to plug in what I already have written up here. And we are going to say the equation of g of x is g of x equals 2 times sine of 4x minus pi over 2. Be careful with that, right? Because the c is the only one that's like the opposite of what we see because it's being subtracted, and then -3. And there we have it. All of that work to dissect this graph for question 6. Thank you so much for stopping by.